Hello everyone. Today we are studying casting process and plastic molding part 2. Introducing myself, I am Mr. Kiran S. Chinswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma in Engineering and Technology. In this slide, we study different learning outcomes. After watching this video, we will able to know what is different types of pattern. Second, different pattern allowances. Third, color coding of pattern. Now we see different types of pattern. Different types of patterns are: first is a solid or single piece pattern. It is subdivided in two parts. First is a flat face or flat block pattern. Second is a symmetrical pattern. Second types of pattern is split piece or two piece pattern. It is divided as a three piece pattern also. Third is a loose piece pattern. Fourth is a gated pattern. Fifth is a pattern with follow board. Sixth is a match plate pattern. 7 is a segmental pattern. 8 is a sweep pattern. 9 is a skeleton pattern. 10 is a built up pattern or shell pattern. And 10 is a lag up pattern. These are some types of pattern. Now we study each types of pattern in details. First is a solid or single piece pattern. Solid or single piece pattern you see in this diagram. They are the simplest types of pattern which are not attached to by plates or gates, screw or risers. They are molded by hand. They may be solid and in one piece having a flat face or maybe symmetrical type of split to simplify the molding. Then it is divided in two groups, that is from flat face or flat back pattern. In diagram there is a second figure which are flat face or flat back pattern. Now we study regarding this pattern. It has a shape so that it can be embedded in a one flask. Each face or back flushes with the layer of sand. It can be withdrawn from the mold after turning the flask upside or down. Next pattern is symmetrical pattern. Symmetrical pattern is it is made in one piece and is molded by taking its one half in drag and other half in a cope. This pattern is made for articles of symmetrical shape so that they can be parted into two exactly equal and similar shape along common center line. Cylindrical shapes are more suitable for this pattern. In diagram you can see single axis symmetrical pattern and second diagram double axis symmetrical pattern. Now we see next pattern is split piece. In diagram you can see split piece pattern. Many patterns cannot be made in a single piece because of molding difficulties. These patterns are made in two pieces by passing a plane through the center line. Their parted pieces are flat and one of faces carries dowel pins and other has corresponding hole to keep the secure position during molding. Now we see three-piece pattern. Three-piece pattern are made in a three parts. You can see in a diagram from top to bottom. At their top there is a cover print and there is a middle portion. This is a taper shaper and their bottom. There are two parting lines. One as upper side, one as a lower side. It is a split pattern with three pieces, also known as multi-piece pattern. Casting having complicated design pattern are required to be constructed in more than 2 pieces to facilitate easy molding and withdrawal of pattern. For 3-piece pattern, molding is done in a 3 different flasks and aligned properly. In this case, we get 2 parting lines as shown in figure. Next is loose piece pattern. In figure, you can see the loose piece pattern. There is a C shape, this is a pattern, and there is a dowel piece, and there is a loose piece. Many times, due to projecting parts, it is difficult to withdraw the pattern from the mold. In such cases, the projecting parts are provided as loose piece temporarily attached to the pattern with dowel pins or nails. While withdrawing, the pattern is first taken out and leaving the loose piece in the mold. Then the pieces are removed. Now we see gated pattern. It is used in a mass production work where many castings are required. A number of small patterns are connected to each other by means of gate formers, which provide a suitable channel for feeding molten metal to these cavities. A single runner may be used to fill all the cavities. These patterns groups connected to each other by gate formers are known as a gated pattern. The gated pattern helps to keep the pattern in a proper position relative to each other. This eliminates cutting of gates, etc. by hand. Also, higher production rate is obtained. This gated pattern is mostly used for mass production. Next pattern is pattern with follow board. In diagram you can see that there is a follow board, then there is a sand and there is a pattern. A follow board is used for thin and delicate pattern. It is a wooden board made to the curved shape of the pattern. When making a mold, the pattern is placed on the follow board. The drag section of the flask is put over the pattern and sand is ramming in the drag. When the outline of pattern are very irregular shape, the follow boards are made of plaster and called as a matches. Next pattern is match plate pattern. In diagram you can see the match plate pattern. Match plate pattern is used with molding machines for mass production work or for producing small casting in large quantity. The cope and drag portion of the split pattern are mounted on the opposite side of the wooden or metal plate, usually aluminum plate known as a match plate. The match plate forms the parting lines of the mold. Aluminum is chosen for match plate because of its lightness and cheapness. One half of the pattern is mounted in a flask and other half in another flask, which are finally assembled to form the complete mold. Next pattern is segmental pattern. A mold of circular work such as rings, gears, wheels, rims, etc. are performed by a segmental or a part of required shape. Sand is rammed above the segment, moving it forward step till in a circle is complete. These are main patterns which are used for producing gears, wheel rims, etc. Next pattern is a sweep pattern. Mold of large size but symmetrical in shape, particularly of circular cross section, can be easily be prepared by using a sweep instead of full pattern. It avoids expensive pattern construction. Next pattern is skeleton pattern. In diagram you can see the skeleton pattern. This method is adopted for very large casting requiring a lot of timber and time to make a full pattern. A wooden skeleton is made from the wooden strip to form an outline of the pattern. The framework is filed and rammed with a sand or loam. A sticker board is used to scrape the excess sand out of the spaces between the ribs so that surface is even with the outside of the pattern. The skeleton is built in two parts, one for the core and other for the drag. After taking the impression, the two flags are assembled together with the core in a position to form the complete mold. Skeleton patterns are used to making casting of hollow CI pipe, beds, wall bodies and boxes. Next pattern is ledge up pattern. In diagram you can see the ledge up pattern. Cylindrical works such as cylinders, pipes or columns are built up with the lag or stave construction. For preparing the pattern, the strip of wood or lags are joined together to the end pieces of the wood called heads by means of nails screwed to glues to form a box-like construction. Now we see pattern allowances. First point, pattern is used to produce the casting of desired dimension. Second point, but the pattern is not dimensionally identical with the casting. Point 3, this is because there are certain mechanical and metallurgical reasons. Point number 4, for this a number of allowances are provided on the pattern to get dimensionally correct casting. Different allowances provided on pattern. First is a shrinkage allowance. Second is a draft allowance. Third is a machining allowance. Fourth is a distortion or camber allowance. And fifth is a wrapping allowance. Now we see this pattern allowances in details. First is a shrinkage allowance. When any metal, cool, is shrink in size, so the resulting casting is slightly smaller in size. Point number 2. To compensate for this, shrinkage rule is used in laying out the measurement. Point number 3. Shrinkage allowance is therefore the amount by which the pattern must be made larger than the desired casting. There is a shrinkage rule or contraction rule. First point, all casting contract in cooling from molten state. Point number 2, to compensate for this, the pattern must be made little larger than the finished casting. Point number 3, contraction is different for different metals and alloys. So, the shrinkage allowance is different for different metals. Second allowance is draft allowance. First point, when a pattern is withdrawn from a mold, there is always some danger of breaking the edges of the mold in contact with the pattern. Point number 2, so tapering or draft is provided on the surface of the pattern parallel to the direction it is being withdrawn. To provide slight clearance, the draft varies from 10 to 25 mm per meter on external surface. Point number 3, on interior surface, the draft is larger, usually from 40 to 70 mm per meter depth. Point number 4, the draft should be minimum so as to maintain uniform metal thickness and minimize the machining. Next allowance is machining allowance. Draftsman indicate each surface to be machined by finish mark, so patterns may provide additional metal to be machined. The amount of this allowance depends on the following factors. First factor A is casting metal, point B method of machining, point C method of casting, point D size and shape of casting, point E degree of surface finish required. Machining allowance varies from 1.5 mm to 16 mm. For small and medium size casting, 3 mm is very common. Next allowance is distortion or camber allowance. This allowance is applicable for casting of intricate or regular shape which get distorted in the process of cooling. Second point, this is due to uneven metal shrinkage. For example, a casting with U shape will be distorted with the leg diversion. So, when casting cooled after its removal from the mold, the legs straighten and remain parallel. Next allowance is wrapping allowance. When the pattern is withdrawn from the mold, it is to be wrapped or shaken. Point 2. By this, the cavity in the mold is slightly increased. Point number 3. In all cases where casting must be uniform and true to pattern, wrapping or shaken allowance is provided by making the pattern slightly smaller than the actual size to compensate for wrapping of the mold. Next, we study color coding of pattern. First point, patterns are carefully finished to produce smooth mold. Point number 2. Patterns are sanded to remove the tool marks and irregularities by sandpaper to achieve the smoothness. Point number 3. Pattern surface is then provided with a coating of shellac to protect it from moisture. Point number 4. The coating is given 2 or 3 times to get all pores or the wooden fill completely and get smooth surface finish. Then application of pattern color coding. Pattern color coding is provided for point number 1 to identify main parts of the pattern from remaining parts. Point number 2 to identify loose piece, core prints, etc. Point number 3 to show the part to be machined. Point number 4 to show the part to be left unmachined. Point number 5 to identify the type of metal to be casted. In this slide, we study widely used and accepted color codes. First color is red. Red color is given to the pattern for surface to be machined. Second color black. Black color used for surface to be left unmachined. Point number 3 yellow. Yellow color for core prints. Point number 4 red strips on yellow base. It is used for seat for loose piece. And point number 5 clear or no color. It is used for parting surfaces. I hope you understand this presentation. Thank you.